cycle ordinary level on trigonometry theory and some practical examples. So we're going to go through the trigonometry background, and then afterwards we're going to go to some exam questions and do out their solutions. Okay, so the first thing there is trigonometry is a part of geometry that concerns solving triangles. So this means finding the length of all of the sides and the measures of all of the angles. For example, we might know that two angles and one side, which is in green, and then you might be asked to find the other angle and sides, which is in red. So if we scroll down here, the following diagram shows the labeling conversion for triangles with capital letters for the angles and lowercase letters for the lengths of the side opposite these angles. So what that basically means is all angles, you can see they use capital letters. So A, B and C, they're all capital letters. Now if we look at the side that's opposite angle A, it's this side here, so we use a small a to signify that side is opposite that angle. If we look at the side B, it's opposite the angle capital B, so again we use lowercase, so small b. And then we have the side C, which is opposite the angle big C, so that's this side here, and again we use lowercase. So when you're labeling sides you use lowercase, but when you're labeling angles you use uppercase. So we're going to look at Pythagoras' theorem. So Pythagoras' theorem is applied to a right-angled triangle. Now you can see here this sign is marked, I've just put an X there. That means that it's a right angle, and a right angle is always 90 degrees. So in a right-angled triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. Okay. First of all, we need to be able to write down or label what the hypotenuse is. So the hypotenuse is always the side that's opposite the right angle. Okay, so I'm just going to put that in brackets. So the hypotenuse is always opposite the right angle. Now, when we're talking about the opposite and adjacent, so the other two sides, for this particular triangle, it doesn't matter which one is which because we're not given another angle. So we'll call this one the adjacent and we'll call this the opposite. So Pythagoras' theorem states that the square of the hypotenuse, so in this case the hypotenuse is c, so c squared is equal to the sum, so sum means added together, so when you add the other two together and square them, so it's going to be a squared plus b squared, and that's what Pythagoras' theorem is all about. We'll be doing some examples of that when we get to the exam questions. Next thing we're looking at is sine, cosine and tan. So given an angle A, now here we're given an angle, so this angle here, and we know that this angle is a right angle, which means that this side is the hypotenuse. So given an angle A in a right angle triangle, we call the sides the hypotenuse, the adjacent and the opposite as follows. Now here it does matter what you call the opposite and which side you call the adjacent. So I've labelled the hypotenuse there, or drawn an arrow to show that that's hypotenuse because it's opposite the right angle. This side here is opposite the angle A, so that must mean that this side is the opposite, and then this side B, so this side here is the adjacent, it's right beside that angle, so we say that that's the adjacent. Now there's a rule, or there's three rules for trigonometric ratios for these angles, and they're defined as follows. So if you wanted to get the sine of A, you put the opposite over the hypotenuse, so in that case it's A over C. If you want the cos of A, you put the adjacent over the hypotenuse. And if you want the tan of A, you put the opposite over the adjacent. So I'm going to write down a rhyme that I usually use to help remember that, because these aren't given in the log table. So sine, so silly, old, Harry. So S-O-H. So sine equals the opposite over the hypotenuse. That's where silly old Harry comes from. Then we have cos, so caught, a herring is a fish, so caught a herring, so cos is equal to A over H, and then tan, so going to be trolling, off America, so T-O-A. And then to write that into the formula, tan is equal to O, so the opposite over the adjacent. So they're the three, and they're the rules there, and I've just given you a rhyme to help you remember them. Now there's a mnemonic as well that they use, SOHCAHTOA, so sine is opposite over hypotenuse, cos is adjacent over hypotenuse and tan is opposite over adjacent. So you can use that either, so whatever you find easiest. Okay, so we're going to go on to an example now. So the example is, suppose that A is 45 degrees. So the angle A is 45 degrees, that's this angle here. Solve the following triangle by finding the measure of all of its angles and sides. Okay, so this angle here is going to obviously be 90 degrees because it's signified by the 90 degree angle sign. Now we know that there's 180 degrees in a triangle. So to get what this angle is here, we need to take 90 and 45 away from 180. So 180 degrees minus 90 plus 45. So when you add 90 and 45, you get 135. So it's going to be 180 degrees minus 135 degrees. And you get 45 degrees. So that's this angle here. So that's also 45 degrees. Now, the fact that both of those angles are 45 degrees, they're both the same, must mean that this side is the same as this side. And that's going back to geometry. So if this side is 1, then that must mean that this side is also 1. So now we can figure out what the hypotenuse is. So this is the hypotenuse because it's opposite the right angle. So we'll call that x. So we're going to use Pythagoras' theorem to solve what x is. So remember, Pythagoras' theorem states that the hypotenuse squared is equal to the opposite squared plus the adjacent squared. So the hypotenuse squared is going to be, in this case, x squared is equal to the opposite squared, which is 1 squared, plus the adjacent squared, which is also 1. So x squared is equal to, so 1 squared is 1, plus 1 squared is 1. So if x squared is equal to, so 1 plus 1 is 2, then x is going to be the root of 2. So that's the answer there, and I'll just scroll down to show you. So there you go, root 2. And we also figured out that the other angles are marked in as well, what I've done above. Now, if we want to write down the sine, cos, and tan of the angle 45, so we'll say we're looking at this angle here, right? Well, then this is the opposite, this is the adjacent, and this is the hypotenuse, because this is the side that's opposite 45 degrees. So if we were to use our rules, the sine, remember, so the sine of 45 is opposite over hypotenuse, silly old Harry. So opposite in this case is 1 over the hypotenuse, which is root 2. And that's where they're getting that from. If we were to get the cos of 45, the cos is the adjacent over hypotenuse, so caught a herring. So the adjacent in this case is 1, and the hypotenuse is root 2 again, so it's 1 over root 2. And then finally tan. So tan is the opposite over the adjacent, and in this case, so sorry, that should be the tan of 45 again. So the opposite in this case is 1, and the adjacent is also 1, so that's going to just be 1. So that's where I got those answers from. And just the other thing is just to check your calculator is set for degree mode when you're doing these calculations out. So we've gone through that bit already, and this question actually I went through that, so I'm going to keep going. Okay, so solving right angle triangles. So these are the kind of questions you'll get on the paper. So find the measure of the unknown angle and the length of the unknown side in the following triangle. Okay, so we'll look at the angle first. So we have this angle here, which is 35 degrees. That's a right angle, so that's going to be 90 degrees. So to get this angle here, we need to take 90 plus 35 away from 180. So it's going to be 180, take away 90 plus 35. So 90 plus 35 is 125, so it's going to be 180 minus 125. And when you do that on the calculator, you get 55 degrees. So that angle there is 55 degrees. Now, they're also asking us to get the lengths of the unknown sides. So we have the angles now. Now we want to get the lengths. So I'm going to use the angle that we're given here, 35 degrees. Okay, and now I'm going to label the triangle according to that angle. So this side here is opposite the right angle, so that's going to be the hypotenuse. This side here is opposite the angle we're looking at, 35. So that's the opposite, which makes the final side here the adjacent. Okay, so we'll try and get the adjacent, or the opposite first. Okay, so we need to use a formula with opposite in it, and also the one that we know, which is the hypotenuse. So what formula uses O and H? And the answer is sine. So the sine of 35 degrees is O over H. So the sine of 35 is equal to the opposite, so that's what we're looking for, over the hypotenuse, which is 6. So what we're going to do then is bring the 6 over here, so it's going to be 6 sine 35 degrees is equal to the opposite. Now if you put that directly into the calculator, 6 sine 35, I have it here, so 6 sine 35 is 3.442. So the opposite, the length of the opposite side is 3.442. So that's that one there. So this is 3.442. Now we have to find the hypotenuse. So I'm going to scroll down here. So we're just after finding out what A is. We know that it's 3.442. Now we can use Pythagoras' theorem to solve this, because we know that the rule is the hypotenuse squared is equal to the opposite squared plus the adjacent squared. So in this case, so this is the hypotenuse, which is 6. This is the opposite, which we're after getting, which is 3.442. And then B there is the adjacent. So we'll fill in what we have. The hypotenuse is 6, so 6 squared is equal to the opposite squared, which is 3.442 squared plus the adjacent squared. So 6 squared is 36. When you square 3.442, you get 11.85. And you add that to the adjacent squared. Now, we want to bring numbers to one side and numbers to one side and then the unknown to the other. So it's going to be 36, take away 11.85, and that will give us the adjacent squared. So put that directly into the calculator. So that's going to be 3.038. That's equal to the adjacent squared. So to get the adjacent, it's going to be the root of 3.038. Now I am just after realizing that I made a silly mistake on the calculator. I'm just going to go back up 2 lines here. So 36 minus 11.85 is actually 24.15. So it couldn't be 3 point something. So 24.15 is equal to the adjacent squared. So the adjacent is going to be the root of 24.15, and that's what you put into the calculator. And when you put that into the calculator, you get 4.915. Now, they've used the cos to get this. So they've used the cos, but I think it's easier to use Pythagoras' theorem there, the way I've done it, just to show you how to get the missing side. So you have 3 sides and your 3 angles there. So we're going to go to another example now. What is the length of the hypotenuse C in the following triangle? So we're looking for this side here, so we'll call that X. So we know that that's 90 degrees. So we'll label our sides next. So this is the hypotenuse. This is the opposite. The reason that's the opposite is because it's opposite the angle that you have, which means this is the adjacent. So you need to pick a formula that has the hypotenuse in it. You can't pick a formula with the opposite because we don't know what the opposite is, but you can pick a formula with the adjacent because we have a value of 2 for the adjacent. So we need a formula with A and H in it. So cot, a, herring, so cos. So cos of the angle, which is cos 50, is equal to A over H. So cos 50 is equal to the adjacent, which is 2, over the hypotenuse, which is X. So in this case, we're going to just do a bit of a manipulation of the formula. So we want to get X on its own. So I need to bring X over here first. We're going to get X cos 50 is equal to 2. And remember, we want to get X on its own. So we need to bring the cos 50 under the equal sign. So X is going to be 2 over cos 50. Now, if you put that into the calculator, you should get 3.111. So x is 3.111. And you can literally type this directly into the calculator and you'll get your answer. Okay, so this is more of a practical example. So a flagpole is 7 meters. So this here is 7 meters. So a flagpole is 7 meters. How long is its shadow if the angle of elevation of the sun is 40 degrees? So there's your angle of elevation. Always angle of elevation it would be as if you're looking up. And what they're asking for us to get is this length L. So again, we're going to mark in what we have. So this is a right angle, which means that this is the hypotenuse because it's always the side opposite the right angle. This must be our opposite because the angle that we have is 40 degrees and this side is opposite 40 degrees, which makes L, which is what we're looking for, the adjacent. So we now need to come up with a formula. It must include the adjacent because that's what we're looking for. And if we look at the triangle, we don't have what the hypotenuse is, so we can't use that, but we can use the opposite. So we need a formula with the opposite and the adjacent. And that formula is going to be tan, so trolling off America. So the tan of 40 is equal to the opposite over the adjacent. So the tan of 40 is equal to the opposite, in this case is 7 over, and the adjacent is L. So we're going to do the same thing as we did in the previous question. I'm going to bring L over here because I want to isolate it. So it's going to be L by the tan of 40 is equal to 7. So then L on its own is going to be 7 divided by the tan of 40. And again, you can put that directly into the calculator and you will get 8.342 meters. And that's the answer. Yeah. So it's 8.342 meters long. So that answer I've just done above. Okay, so we're on to some exam questions now. So the first one I have here is 2011 paper 2, question 13. So Vera is standing on a level ground beside a building on a sunny day. She is 1.6 meters tall and her shadow is 0.5 meters in length. The building casts a shadow which is 6.2 meters long. Draw two triangles to show this. Okay, so the first one there is Vera herself. So she's 1.6 meters tall. It's going to draw it like this. So that's going to be 1.6. We'll say she's 1.6 meters tall. She casts a shadow of 0.5 meters in length. So this is her shadow. We're going to say that's 0.5 meters in length. And to draw your triangle, you just join up these two. So that's for Vera. And for the building, the only thing we're told is that it casts a shadow which is 6.2 meters long. So the building will obviously be bigger, but it casts a shadow which is 6.2 meters long. So this is going to be 6.2 meters long. And that's all the information that we're given. Explain how this information can be used to find the height of the building. Now we can use the fact that they're similar triangles to find the height of the building. So I'm going to go with that one. So the fact that they're similar triangles. The next question actually asks us to find the height of the building. So that kind of puts the similar triangle concept into play. So with similar triangles, we're going to use the information that we have. So they're asking for the height of the building. So this is what they're looking for here. Okay, so if we were to write down the ratio, because they are similar triangles, we could say that 1.6, which is the height of Vera, over this height here, which is what we're looking for. So 1.6, the ratio 1.6 over h, which is the bigger triangle, is the same ratio as 0.5, which is this, over 6.2. So 0.5 over 6.2. All you have to do then is cross multiply. So you're going to get 0.5h is equal to 1.6 by 6.2. So put that all directly into the calculator and you'll get 0.5h is equal to 9.92. Now to get h on its own, it's going to be 9.92 divided by 0.5. And again, you can put that directly into the calculator. When you do that, you'll get 19.84 meters. So this height here is 19.84 meters. Now the next question is to find the angle of elevation of the sun correct to the nearest degree. So find the angle of elevation of the sun correct to the nearest degree. So the angle of elevation of the sun is going to be this angle here or this angle here. So remember, it's the angle when you're looking up. So I'm going to use this triangle here. So if I was to mark in those sides, so there's your right angle, this is the hypotenuse, this is the opposite, and this is the adjacent. So we want to look for this angle here. I'm going to call it x. So we use O and A, so that's a formula that we have. So O and A, we have 1.6 and 0.5. So I'm going to draw this triangle out again here. So we have 1.6 and we have 0.5. And it's x that we're looking for. This is the opposite. This is the adjacent. So we need a formula with opposite and adjacent because we don't have what the hypotenuse is. So it's going to be tan. So the tan of that angle x is equal to the opposite over the adjacent. So we can fill in what we have. So the tan of x is equal to the opposite, which is 1.6, over the adjacent, which is 0.5. Now, that's what the tan of x is. I want to get what x is. So what we need to do is bring the tan over or under the equal sign. When we do that, it becomes what we call the tan inverse. So the tan minus 1 of 1.6 over 0.5. Now, I'm just going to make a note here. To get the tan minus 1, you press the shift key on the calculator and then press tan. When you do that, tan minus 1 will come up. So if you put that directly into the calculator, you get the tan minus 1 of 1.6 over 0.5, you will get 73 degrees because it asks it to correct it to the nearest degree. And that's the answer to that question. I think that's the full question done. Okay, so we're on to 2013 paper 2, question 5. Okay, so use your calculator to find the following trigonometric ratios. Write each answer correct to 4 decimal places. Now, you are literally typing into the calculator sine of 25. If you type that into the calculator, you'll get 0.4226, and that's correct to 4 decimal places. The cost of 39, you're doing the same thing again. Literally type the cost of 39 into your calculator and you get 0.7771. Then the tan of 40, again, type it directly into the calculator. You get 0.8391. So they're straightforward enough. So the angle P is shown in the triangle below. So this is your angle P. On the diagram, clearly label the side opposite the angle P. So label the side that's opposite the angle P. So this is going to be the opposite here because this is the side that's opposite that angle P. Then it says clearly label the side that's adjacent to angle P. So the adjacent is the one that's beside it. So this is going to be the adjacent here. And then if the length of the opposite side is 9 and the length of the adjacent side is 12, find the length of the hypotenuse. So this is Pythagoras' theorem. So Pythagoras' theorem states that the hypotenuse squared is equal to the opposite squared plus the adjacent squared. Now, if we look at that triangle, we don't have what the hypotenuse is. That's what we're looking for. So the hypotenuse squared equals the opposite squared. So that's going to be 9 squared plus the adjacent squared, which is 12 squared. So the hypotenuse squared equals, so 9 squared is 81 plus 12 squared, which is 144. I'm just going to continue it up here. So the hypotenuse squared is equal to, so 81 plus 144 is 225. Now, that's what the hypotenuse squared is, but I want to get what the hypotenuse on its own is. So that's going to be the root of 225. Put that directly into the calculator and you will get 15. So the hypotenuse is equal to 15. And that's the end of that question. So another one here, 2013 paper 2, question 6. Jasmine wants to find the height of her house. She measures the angle of elevation of the top of the roof using a clinometer. It's just an instrument that she uses. The angle is 30 degrees. We can see that on the diagram. She is standing 18 meters from the point on the ground directly below the apex of the roof. Jasmine draws the diagram above to show this information. Use Jasmine's measurements to find x and write your answer in meters corrected 1 decimal place. So what we're looking at is this triangle here. So I'm going to redraw that in terms of what we have. So there's your triangle. So this is 30 degrees. This is 18. And we are looking for x. So the first thing we always do with right angle triangles is label what we have. So this is the right angle, and that's in the diagram there, you can see it. So that's going to be the hypotenuse. This is the opposite because it's opposite the angle 30 degrees, which makes 18 the adjacent. Now we are being asked for x, which is the opposite. So we need a formula with opposite in it. We don't have what the hypotenuse is, but we do have what the adjacent is. So we need a formula with O and A, and that's going to be tan. So the tan of 30 is the opposite over the adjacent. So we just fill in what we have. So the tan of 30 is equal to the opposite, which is x in this case, over the adjacent, which is 18. So we want to get x on its own. So we want to isolate x on its own, which means bringing 18 over here. So you're going to get 18 multiplied by the tan of 30, and that will give you what x is. Now if you put that directly into the calculator, and it's asking us to give it to 1 decimal place. So if you put that into the calculator, you will get, so 10.3923, so round that to 1 decimal place, that's going to be 10.4 meters. I think there's one more part to this question. What other information is needed to find the height of the house? Now because Jasmine is she's measuring using a clinometer, and you've just figured out based on that other calculation, you would need to know Jasmine's height as well. So that's the answer to the last part. So that's it for this week. I'm going to attach some extra links to some extra video tutorials, and I recommend that you follow them. So there'll be extra material based on trigonometry and some more questions and video tutorials on how to actually answer the questions as well. So I recommend that you do that, and I'll speak to you next week.